Number 5. Now when you look at it, it's monic. That's great, right? So normally you just think of a pair of numbers that does what? Adds to -1 and multiplies to -3, right? Except you think and think and think. You don't get very far, do you, right? Because 3 is prime. So your only choices are 1 and 3, right? And no matter which ones you make negative, they're never going to add up to -1. We learned a new technique, not factorizing. We learned a new technique for handling these kinds of questions, right? What do? We're going to complete the square, okay? So hold on to your hats. Let's write out the question. To complete the square is this -3 over here. It's what's stopping this thing being a perfect square. We want this to be a perfect square. Put it over the other side, get them out of the way. Okay? And now I've written this, you notice I always leave this gap here. That gap is so I can add something in to complete the square. Okay? So here, there's a -1 there, right? So what number do I add to complete the square? I have to take that -1. I have to halve and then square. Halve and then square. That's the number which will make this left-hand side a complete square. Okay, a perfect square. So when you halve it, that gives you -1/2. And when you square that, you get 1/4. Are you okay with that? I add it to the left, I better add it to the right. Okay. All right, now once I have that, the reason why I did that to the left-hand side is because now it's a perfect square. What's a perfect square of? I'll give you a clue. It starts with an X, okay? You can start to narrow this down, right? See how there's a minus sign there? That means there has to be a minus here, right? And the number that we got here, which halved, that's going to be the number that ends up here. It's a half, okay? Because remember, if you went backwards, if you went up there and you expanded this, right, that half would get squared and turned into 1/4, right? Okay, so now I have, what's this, 3 1/4. Is that going to be something nice? It's like 13 over 4. Not really. So I'm just going to leave that as 3 1/4. Okay? All right, this is great now. It's factorized, kind of, by using this complete the square business, but I want to get that x by itself. So, next step, I'll take the square root of both sides. Good. That gets rid of the square on the left-hand side. What does it do to the right? It gives me the square root, right? But also, just like if I gave you the equation x squared equals 25, x is not just 5, right? There's another number which does that. It's plus or minus, right, good. So just like it's plus or minus there, I'm going to get plus or minus here, okay? And now there's just one last thing to do. To get that x by itself, push that half over the other side. Now, I suppose you could probably neaten this up, you could do some rationalizing business, but honestly, this is the main thing we're trying to work out. Can we complete the square here, go through this series of steps, because it's quite tricky, right? And the fact that it's quite tricky is something we'll deal with later this lesson, okay? Okay, last tricky one, yeah?
How did you arrive in the x minus half square?
This go here to here. Question? Yeah, okay. So let me give you a simpler example perhaps, okay? If I gave you an example like this, let's make it, no, I'll make it a minus. Okay, so here's an example, right? Now the reason why this is easier is because I'm not going to end up with fractions, right? So I deliberately gave you one that was a bit hard to push your limits a little bit. If I complete the square over here, I'm going to get that 5 over the other side. Okay, and then I think, what will I add to this? What will I add? Now, I have a 2 out there, so what number do I need to add to complete the square? It'll be 1, right? I halve it, which gives me 1. Square it, which gives me 1. Okay, but I need to take advantage of the fact that I recognize all those when I have been given questions, and can you square this? And can you square this? Can you square this? They all end up in this same kind of format, right? Just like you learn to recognize square numbers, like that, right? You're like, oh, you look at a number, you think, I know that kind of number, I recognize it, right? This, algebraically, is the same kind of thing. It's a square, but in algebra terms, right? So you look at that, you think, I know what this is, it's that guy, right? So that's how I went from here to here. It's not really clear in terms of working because there isn't much working to do. It's a recognition thing. right? So that is part of what's hard about completing the square, which is why I'm going to teach you an alternative to complete the square today. Okay, now 6 is a bit more challenging, right? Because again, it's not monic. Every time you add more of those kinds of layers of complexity in, it's hard, right? So 3x squared plus 2x minus 1, okay? Again, you look, you think, can I factorize it?
Yeah, yes.
What would you do? What pair of numbers do you want? Yeah.
-3.
Okay, so if I go 3x squared, hold on, negative 3? Positive 3, negative 1? Right? So positive 3, negative 1. Oh, sorry, that's an x. Minus 1. Okay. So I can factorize this guy by taking out 3x. And here, that's just going to be x plus 1. I'm actually going to stop there if that's okay, because I think you guys know what to do after that. You're going to pair them up. You're going to read your solutions off. Okay. So, last one under the review, and I'll admit it's a bit sneaky. But when you have a look at it, who's had a go? Who's hands up, straight? Okay, I'm going to pause for a second. That's not many of you. I want all of you to have a try at it. Wherever you're up to, just pause, maybe leave a bit of space if you need to, and have a go at number 7. I've already walked you through how you might do those earlier questions, and you can use the same techniques. Just give it a shot. Just see what happens. I'm going to unpack this the same way I did before. I can't think of my factorization neatly, so I'm going to give this completing the square business a shot. Okay. That plus 2, I want to make it a negative 2 on the other side, like so. And then I think, ooh, okay, what will I add to this to complete the square, right? What do I add? I add a quarter again, don't I? Okay. Now, when you look at the left-hand side, you think, sweet, I've done my perfect square business. That was the whole point, right? So when I factorize this, right? But then we go to the right-hand side, minus 2 plus a quarter. I'm doing my numbers right. Now, you agree with that? Is that okay? Does that check out? Now, this is a problem. This is a problem for us. It's a big problem, right? Because we're saying there's some number where if you square something squared, you will get a negative number. Something has gone wrong, right? Because no matter what number you put in there, you can put in a positive number, you can put in a fraction, you can put in 0, you can put in a negative number. No number that we are familiar with can be squared and give you a negative number. It just sort of, okay? What will happen if you get your calculator out and you say, well, maybe my calculator will help me out, and I'll put in square root of negative 1 3/4, right? And it does that ever so unhelpful thing and says math error, which is basically, it's kind of like the calculator's equivalent of saying, well, I don't know, okay? So what are we going to do with this, right? As it happens, at this point, once you recognize that it wants to square and get a negative, there aren't actually any solutions to this. And so we say no real solutions. That's it. You can pack up and go home. You don't have to just sort of wonder, what does this mean? It means there aren't any solutions, okay? Now, this is not the main point of our lesson today, but because it just naturally comes out of this, I want to show you what this means. See this quadratic up here? X squared plus x plus 2. One of the big reasons we go through all of this exercise of factorizing, blah, 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 is so that if I took the same thing, x squared plus x plus 2, and said, let's make y equal that, I can graph this thing. Okay, I can graph it. I can draw a picture of what it looks like. You guys have seen parabolas before, right? Now, this is a bit of a strange parabola, so I've just done my normal thing, which is when you don't know what something looks like, you just start plotting some points. Okay, I know how to do a table of values. You can do that for anything, even if it's really weird and complicated. Okay, so this is my table of values. You can go ahead and you can check it out. For x equals negative 1, for instance, how did I get that? Negative 1 squared is 1 plus negative 1, so those goes cancel, they just leave you with the 2. If I put in x equals 0, 0 plus 0 plus 2, you get the idea, okay? So off of this, bless you, I have 4 coordinates, okay? So I'm just going to quickly draw these in, right? Minus 1, comma 2. Where might that be? We go minus 1, 1, 2, 3, 4, 5, 6, 7, 8. Let's put that about there. Here's my first point, minus 1, comma 2. This guy, 0, comma 2, is going to be here. This guy, 1, comma 1, 2, 3, 4, something like that. And then 2, So 2, 8. Okay. Now this is all I've traced out so far. I know that parabolas, every single parabola in the world is symmetrical. So if I'm getting a shape here, I'm guessing it's going to do something like this. Okay. Now you have a look at this shape. It's not going to win any art awards, okay? But I could off it. Can you tell me, when is this graph equal to 0? Where does it intersect with the x-axis? And the answer is it never does, right? It's keep going up this way, and it's going to keep going up, and that's as low as it goes. It never comes beneath. So it never hits the x-axis. But that's when does this thing hit the x-axis? 0. And our conclusion was it doesn't, right? In fact, lots of quadratics don't. They just never intersect. Okay, so this is what that means. This is actually what the picture is telling you. Okay, so there are no real solutions, and you will get, quadratics like this. And we're not trying to trick you. We're trying to see if you recognize, like, what's the meaning of this thing. A classic error that students make is they get to here and they think, oh, well, there's a negative. My calculator tells me math error, so I guess I'll just take out the negative, right? And then take that square root, because that shows we don't really understand what's going on. Okay, so that negative is meaningful, and it means there's no real solutions. Okay.